Good afternoon. Welcome to Cogniflight Cloud, where we're revolutionizing safety for single cockpit aviation. Here's a fun fact. Solo pilots in small aircraft have to manage navigation, communication, weather monitoring, and stay alert, all without a co-pilot to nudge them if they are getting drowsy. It's like juggling a riding unicycle, except at 10,000 feet. That's precisely why we created Cogniflight Cloud, to give ground control teams the superpower of real-time pilot monitoring. Our platform transforms telemetry data from single cockpit aircraft into actionable insights that ground control can use to ensure pilot safety. We're processing massive amounts of flight data through machine learning algorithms that detect fatigue patterns before they become critical. Think of it as having a virtual co-pilot on the ground watching over every solo flight. Through Docker containerized services, MongoDB databases, and real-time MQTT streaming, we're building a system that bridges the gap between isolated cockpits and ground support teams. Our React dashboard gives controllers an intuitive interface to monitor multiple aircraft simultaneously, ensuring no pilot flies truly alone. Now, let me hand it over to Susan, who will walk you through the 7 functional requirements that make this groundbreaking safety net possible.
Thank you, Jeremiah. So the functional requirements of our cloud platform have to do with receiving, processing, and analyzing data from devices to provide fatigue analytics and data visualization through reports and dashboards. The key requirements are number 1, user authentication and management. This includes registration and profile management. It provides role-based access control and password hashing and verification for security. Also, cloud data integration and processing, including receiving data from edge devices, real-time data streaming, and data storage. Then we have edge node cloud management as the third functional requirement. The next slide, Jason, please. So this includes the registration of edge devices on the cloud platform, and generating and managing API keys for authentication, as well as remote monitoring and tracking of the edge node connectivity status. Fourthly, we must have a machine learning analytics engine to process the telemetry data and provide fatigue prediction and analysis. Machine learning algorithms should provide real-time predictions on incoming data from edge devices. Communication between the machine learning engine and the back-end will be socket-based. We will have a web-based dashboard interface that is user-friendly and responsive for multiple devices. It will provide real-time visualization of telemetry data and trends based on historic data. There will be an export functionality for reports. Our platform will provide chatbot integration, including a natural language interface for data queries. It will provide a platform navigation assistance and insights and recommendations automatically. Lastly, the platform will provide API services, which will include RESTful endpoints for data access, information retrieval, upload, and management services, including image uploading for facial recognition. And it will provide third-party integration support. Over to you, Brian, for the non-functional requirements.
Thank you, Susan. These requirements concern the sort of architecture-specific things, the large-scale things that's needed for this to be a feasible solution. Firstly, we have the performance requirements that concerns responsiveness and latency and throughput. So for the different APIs and query engines that we're going to be setting up, there's an upper bound on how quick or how slow these things can be. And we also have the constraint that we have to be able to process up to and more than 100 gigabytes of telemetry data every day. And we also have very strict security requirements, specifically for things like man in the middle, for things like cross-site request forgery, and probably cross-site scripting things as well. This will continuously be audited through the process of our development cycle. And so far it includes all the things that are listed there. For the scalability requirements, obviously if you're actually using this thing, it has to It has to be able to scale, especially horizontally, for use and integration between different sites, different airports and whatnot. And it has to be able to scale conveniently for especially more and more pilots and more edge nodes and more machine learning things. There's going to be a lot of machine learning. And most of this is going to be powered and supported by Docker. That's the reason we chose it. And then for the reliability, that's also coming heavily from Docker and from our cloud hosting service. We can, because of our cloud hosting service, we can guarantee a 99.5% uptime of our server in production. And Docker also provides the automated container restarts, data persistence, and the MongoDB replication is also going to be very simple later if this thing has to get horizontally scaled. And InfluxDB has retention policies that we can use for the amount of telemetry data that we will be storing. Next slide, please. And then for the maintainability, this is again a facet where Docker really helps, because Docker acts as this glue that glues all of these different parts together. And because Docker is sitting here in between all of these things don't have to worry about integrating with each other very tightly. Docker can sort of figure large parts of that out for you. And many of these things can be updated and worked on independently. And we do have configuration set up so that I can sit and work on the back end while Susan sits and works on the front end, and we won't really cause trouble for each other. And then for the portability requirements, that's also provided by Docker. And the development and operations, I've accidentally mentioned it already. This is very much what Docker can do as well. There's different environments that I've set up for development and for production. And this works in cooperation with the React Vite, which we also chose for all of the hot reloading stuff. It's got some very powerful tooling to make the front-end design a lot easier. And the Docker also allows us to create these automated build processes and orchestrate all these containers together effectively and remotely and reliably without worrying about all those little nitty-gritty things that you do if you script all these things manually. Thank you for your time. I'm giving over to Jeremy for the next section.
Good day, ladies and gentlemen. In this part of the presentation, we will discuss why Scrum was chosen as our selected agile methodology. Let's go to the next slide. The first reason in this case why it's chosen is because of its complex cloud architecture management that we're going to implement in this project. As we know, Scrum excels at managing complex multi-service architectures, and as a result, in this project timeline, we will develop clear sprint goals, which will then help coordinate the back end, the machine learning, and the front end development. The product backlog will then effectively track the features across all cloud services. Let's go to the next slide. The second reason will be the iterative cloud service development. This will pretty much allow us to build and deploy the cloud services on an incremental basis, pretty much like either weekly or daily basis. And within each sprint, we will pretty much deploy Docker containers. As we produce more sprint deliveries, this will help us to improve the cloud capabilities in this particular project. Let's go to the third slide. The third option in this case would be the technology of integration challenges. Scrum's empirical approach will then suit integrating programming languages such as Go, Python, React, and database software such as MongoDB and InfluxDB, which with each sprint reviews validating the service integration. This will be demonstrated by the demonstrations that we do in these particular presentations for the purpose of the academic assessments. Let's go to the next slide. The fourth option in this case would be because of the academic timeline management, because this is an academic project, we pretty much implement sprints on a weekly basis, which will then align with our assignment deadlines. The sprint deliverables will then align with the overall project milestones of this project. As a result of this, regular demonstrations will be done for academic assessment. And let's go to the last slide in this case, which is pretty much explaining the team expertise distribution. As you know, this team, I believe, is one of the best teams in the world in terms of this particular project, as we have a diverse case of skills that you can implement in this project to make it go boom. The Scrum accommodates our team perfectly because we are about 8 different people with distinct roles for each person. With Jeremiah being the product owner, Jason being the Scrum Master, and the rest of us being the 5 developmental team members, with Brian being the backend developer, Jaden, Suzanne being the 2 front-end developers, and me and Yanku being the 2 machine learning developers. And as a result of this cross-functional collaboration, it would then be essential towards the success of this particular cloud platform application. I'll hand this over to Jason and Jaden for the rest of the presentation.
Thank you, Jeremy. So I'll be going over the product scope and then also the user feedback for cloud services. So firstly, for the product scope for the cloud platform complexity, Cogniflight Cloud uses a multi-service architecture, which makes Scrum an excellent fit for managing complexity. With Docker services management, each service like MongoDB, InfluxDB, and Mosquito, the backend, the machine learning engine, and the front end can be developed in parallel sprints. Through sprint planning, we can identify and manage service dependencies early, which keeps development smooth. Deployment to the cloud happens incrementally, so we deliver value step by step rather than waiting for a big release. And finally, integration points are checked during sprint reviews to make sure all services communicate effectively. So we can go on to the next slide. For user feedback for cloud services, one of Scrum's biggest strengths is feedback, which is vital in evolving a cloud platform. In sprint reviews, we demonstrate features like the cloud dashboard and API functionality to gather stakeholder input. That feedback validates both performance and analytic accuracy. Each sprint also includes performance testing, such as cloud load testing, to ensure the system scales. Security is another priority. Regular security reviews are carried out on cloud endpoints, and lastly, API evolution is continuous. We identify and adapt API iteratively based on integration feedback. I'll now be handing it over to Jason.
All right. So now we basically have the timetable here and what we would like to achieve for each sprint. So as we can see right in front of us, in sprint 1 and 2, we will be creating the foundation for the cloud platform through the Docker environment setup, configuring of MongoDB and InfluxDB, creating fundamental basic authentication services, creating the initial API structure, and adjusting user and settings management. So once again, this is for the fundamentals for the first sprint. Then in sprints 3 to 4, we will be creating the data pipeline. We will be using MQTT broker integration. Then we will be creating the telegraph metrics collection through the use of time series data storage. We will also be managing the edge node, making sure the edge nodes capture information effectively, and then we will be creating a basic dashboard. Now in sprints 5 and 6, we will be creating the intelligence layer through the use of fatigue analytics implementation and machine learning integration, AI chatbot development, advanced visualizations through the use of the dashboards, and flight tracking and alert management. In sprints 7 and 8, we will be focusing on production readiness. We will be deploying it on the cloud through the use of either AWS, Azure, or VPS. We will also be doing performance optimization, making sure that the security is fundamentally sound. And then obviously we will have documentation completion. So as you can see, each sprint has a fundamental objective and is broken down into manageable timelines, which is critical for a project of this ambition. So Scrum helps us to coordinate our diverse technology stack. The daily stand-ups allow us to synchronize work across the various parts of the project through the use of Go on the back end, Python machine learning, and React on the front end. Sprint planning allows us to estimate the effort that is required for the use of these different technologies like Docker, MQTT, and InfluxDB. Now, we will also be defining how we determine whether a project is done or not through the use of cloud deployment criteria. And with technical debt, we will track containerization and cloud optimization needs. And then through the use of sprint retrospectives, we can look back and improve cloud development processes for the next sprint. I will now be handing over to Janku.
Thanks, Jason. Now let's look at why Scrum is especially beneficial for our project, Cogniflight Cloud. So first, Scrum allows us to evolve cloud services rapidly. By using 1-week sprints, we can continuously deploy new features and improvements. This means that if there is a bug or a security patch comes on, we don't have to wait for a long release cycle. We can deliver the fixes in the next sprint. It also helps us roll out new machine learning models or APIs without disrupting the rest of the system, thanks to the containerization that Docker provides us. Secondly, you can go to the next slide, Jason, 5.2. Secondly, Scrum ensures continuous quality. Every sprint includes testing at multiple levels, unit integration, load testing, and even validation of the machine learning models. This way, issues are caught early before they can become bigger problems. Automated testing of APIs and performance monitoring also help us maintain stability while scaling. Third, Scrum helps us coordinate services efficiently. Daily stand-ups keep all team members aligned, from back-end and machine learning developers to the front-end team. This reduces miscommunication and makes troubleshooting more collaborative and ensures that everyone understands how the data flows through the system. The Scrum roles are also here. Jason, our project owner, keeps the vision clear, and the Scrum Master makes sure that blockers don't slow us down. Fourth, next slide, Jason. Scrum gives us predictability in our delivery. By tracking sprint velocity, we can estimate when features will be completed and align them with academic deadlines. This reduces our last-minute rushes and provides the stakeholders with confidence that the platform is on track. And then finally, Scrum brings transparency and governance. The product backlog provides a clear roadmap of what is being developed, and sprint reviews let stakeholders see real working features rather than just progress reports. Over time, this builds trust, ensures compliance, and gives visibility into costs, resources, and risks, which help us by using this project to get us ready for the industry. So overall, Scrum doesn't just help us manage complexity, it ensures that Cogniflight Cloud grows into a structured, transparent, and high-quality way. I'll be then handing over to Jeremiah to close for us.
And that brings us full circle. Cogniflight Cloud, where ground control finally gets X-ray vision into single cockpit operations. Scrum has proven to be the perfect framework for our 7-person team to tackle this complex challenge. From Brian's Go Backend to Jeremy and Janku's ML engine and Jaden and Susan's dashboard interface, we've orchestrated multiple technologies into one cohesive platform. Scrum's iterative approach lets us deliver working software every sprint while continuously refining our fatigue detection algorithms. The impact? We're empowering ground control teams to provide unprecedented support to solo pilots. No more flying blind about pilot conditions. Our platform ensures that every single cockpit aircraft has the safety oversight it deserves, turning isolated flights into monitored missions. With real-time analytics, intelligent alerts, and cloud scalability, Cogniflight Cloud is set to make single pilot operations safer than ever before. Thank you for your attention, and remember, in aviation safety, the best backup isn't in the cockpit, it is in the cloud. And lack a day.